Hey, welcome back to my second foray into creating these SAT 2 Mathematics 2 subject test videos. This is SAT Math Teacher, or Andrew. And yeah, I'm going to go through another Mathematics Level 2 subject test. Another one of those Dubai tests that were released on the internet. I had a whole spiel in the first video that I made. Not going to say all that stuff again. But basically, this is not Dubai Test 2. This is Dubai Test 10. Alright, so just for the record, this is Dubai Test 10. So, let's see. We're going to go through this test. I don't know any of the answers. I haven't seen the answers. I haven't seen the questions. I am looking at this for the very first time, and the goal of this is for me to show you my thought process as a math teacher. And to just sort of hope that you, from me looking at these for the first time, see if you can gather anything off of that. And my goal, inevitably, is to get the fastest way to solve these problems. So it's not just solve them, it's solve them in the fastest way possible. So we're going to do our best, and we'll see where we get. We're going to start with question number 1, and hopefully get all the way to question number 50. And I'm going to make sure I'm recording. Yes, I am. Everything looks good. And yeah, I mean, I highly recommend doing this test along with me. So either, do 5 problems and then come back to the video and watch how I did those 5 problems. Then you do 5 problems and watch me do them. Or if you want, you can do it problem by problem. Or feel free to take the test like it was a real test, and then grade yourself, and afterward come back and watch the problems that you're most interested in. Maybe the problems that you got wrong, the problems that you were confused about. That's another great way. I just don't recommend blindly watching this video and just maybe doing some of the problems in your head, ignoring some of the other problems, whatever. I don't necessarily recommend that. You can, I guess, but I just don't necessarily recommend that too highly. So, the one thing that differs in this video from my first video is I bought a drawing tablet. So I have a drawing tablet, which means that my writing will hopefully be a little bit better, and a little bit neater, and a little bit easier to read. Although I don't have very neat handwriting in real life, so that's not going to change. But at least I'll be able to write with an actual pen, as you can see, which is pretty cool. All right, yeah. Let's start. So we'll go to question number 1 and begin. All right. So, let's see. Does this work? Hello! It does. How beautiful. What is the greatest common divisor of the 3 integers 144, 216, and 360? Okay. So a greatest common divisor problem. What is a greatest common divisor? If you have a couple numbers like A, B, and C, a few numbers, the greatest common divisor of A, B, and C, if you list out all the factors of A, all the factors of B, and all the factors of C, the greatest common divisor is the product of all of the factors that all 3 numbers have in common. Okay. Looking at this problem, I mean, so if I go into this on test day, what I would probably do is write out these numbers and figure out their prime factorizations, or make a little factor tree. So maybe I would do this. Maybe I would make a factor tree for each of these numbers. It's pretty quick. 144, that's a perfect square. That's easy. 216, you should know 216. This is a perfect cube. It's 6 times 6 times 6. You should know that. So maybe we can write it as 36 times 6, which is, of course, 6 times 6. We'll break the 6's down into a 3 and a 2. These are called factor trees, in case you haven't seen these before. I think a lot of schools teach factor trees, but if you haven't seen these before, basically I'm just writing out all the pairs of factors. Making sure I'm in the center of my camera. Appears I am. We're good. So 360 would be maybe 36 times 10. I see a lot of 6's, so I'm interested in these 6's. It's probably going to come into my greatest common divisor. Divisors are the same thing as factors. Divisor and factor are effectively synonyms. Okay, so now let's take a look at this. So I'm noticing a lot of 6's. Let's use a different color. We'll use red. And I'm actually going to, this is my little palette here. I'm going to bring this onto the screen. All right, so I'm noticing these sixes. Here's 1 6, 2 6s, 3 times 2, 3 times 2. There's 2 6s in 216. There's 2 6s in 360, which means that the greatest common divisor is at least 36, because there is a factor of 36 in all 3 of these numbers. So it is at least 36. Let's see, are there any other common factors here? Well, I think all of them have a spare 2 left over, not circled. So I think we can multiply by 2. So 36 times 2 is, of course, 72. And I believe that 72, because if we just look at 144, the next one, well, okay, a few different reasons why it has to be 72. It could be something greater than 72, but immediately we know it's not something greater than 72, because we can't use these, just so you know, because 72 is the greatest number of the 5 numbers that they give you, of A through E. So it has to be 72. We have eliminated the possibility of it being A, B, C, or D, so it must be E. Yeah, and I mean, let's say you were unsure about that answer. You could always use a calculator and make sure that you can divide 144, 216, and 360 by 72. I'm fairly confident that you can. Looks good to me. First answer is E. All right, let's take a look at the second problem here. Go with blue. If the graph of the parabola y equals ax squared plus bx plus c opens up, which of the following must be true? So opens up, which means it looks like a smile. So here's the graph of our parabola. Which of the following must be true? A must be greater than 0. Yeah, that sounds pretty true. Yeah, C must be greater than 0. No, not necessarily. C could be less than 0. The only thing that C determines is where it intersects the y-axis. So C could intersect the y-axis wherever it wants, and the graph could still open up. That would be fine. A has to be greater than C. No, I can find a counterexample to that fairly easily. C doesn't determine anything. If, let's say A was 1 and C was 2, then your graph would still open up. B squared minus 4ac is greater than 0. B squared minus 4ac is considered the determinant. It's found in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over twice a. So there's that b squared minus 4ac. So this being greater than 0 does not determine whether it opens up or down. What that determines is the number of real solutions. So if it's greater than 0, you're going to have 2 real solutions. If it's less than 0, you're going to have 0 real solutions. Both of your solutions will be complex. And if it is equal to 0, you will have 1 real solution with multiplicity 2. Or, real root, I should say. So both of these are not relevant. This I can find a counterexample to, I promise. And this doesn't determine anything about opening. A is the part that determines whether it opens up or down. If A is positive, then it opens up. If A is negative, it opens down. If A is 0, then it's not a parabola. So, yeah, the answer is I for number 2. Hopefully that all is clear. Okay, so let's scroll on down to number 3. Looks like we can't get 3 and 4 on the same page, so we'll do that. All right. What is the 5th term of a geometric sequence whose first 3 terms are 486, 162, and 54? All right, what is a geometric sequence? A geometric sequence is a sequence of numbers that the common ratio between those numbers is a multiplicative ratio. So to go, and it's common between all of the numbers. So first number is 486, and the second number is 162, and the third number is 54. Then we are doing something to 486 to get it to 162. dividing it, or we're multiplying. You could think of it as multiplication or division, but you're multiplying it by some number r, common ratio, and that's going to give you 162. And we can figure out what r is by simply dividing 162 by 486. So let's do that right now. You should use a calculator. Take advantage of your calculator since you have it. 162 divided by 486. 0.3 repeating. Okay, so that means that r is equal to 1/3. We can verify that by noticing that 162 is 54 times 3. So 162 divided by 3 is 54, or 162 times 1/3 is 54, whichever you'd like to say. Okay, so here's our third term. This means that our fourth term is determined by dividing 54 by 3, which you could use a calculator if you wanted, or you could kind of just think about that, and hey, that's 18. And then the fifth term is when you divide 18 by 3, which would of course be 6, and that is exactly what we're looking for, which means that our answer for number 3 is D. Fairly confident about that. Yeah, is there a faster way? Faster way that we could do this? Maybe, we could forego the use of a calculator, and instead of looking for the common ratio between 486 and 162, look for the common ratio between 162 and 54. They have to be the same, since it's a geometric sequence, and it's a lot easier to think about 162 divided by 54, and it's fairly easy to notice that that's 3, or you're dividing by 3. It's 1/3 is the common ratio, the ratio, I guess. So that might be a little easier to see. You may not need to use a calculator. I mean, you're kind of, I would say it's a pretty fair assumption to make that their common ratio is not going to be like, I mean, it has to be rational. I would say it's probably not going to be some crazy rational number, but you could probably assume it's going to be a nice number, and yeah, it's 1/3. So easy to see. Maybe use the second two numbers. Use smaller numbers in general is going to be the guide for that. All right, keep it moving. Can I get 4 and 5? Not really. Let's go with number 4. In triangle ABC above, x equals 55 degrees. Okay, so we'll put a 55 in there. I always say to label your figures egregiously. Like, if they're not labeled, label them. Every little thing. What is the value of h? Okay, so we have a 55-degree angle. We have 10 h and an unknown everything else. Note figure not drawn to scale. I don't think that's helpful. Well, I think this is where our good old trigonometric identities and functions are going to come into play here. So I think we know that the sine of x is equal to h over 10. The sine of x equals h over 10. Sine is opposite over hypotenuse. Yep, that makes sense to me. So, if that doesn't make sense to you, refresh your trigonometric identities. Understand SOHCAHTOA. Sine equals opposite over hypotenuse, etc. So that's the only thing I'm using here. I actually, we know x. So the sine of 55 degrees equals h over 10, which implies that 10 sine 55 is going to equal h, which is going to be our answer. And from this point, you grab a calculator, because you probably don't know the sine of 55 degrees off the top of your head. So you do 10 sine 55, and you should get 8.19. And that's your answer, 8.19. Now, make sure your calculator, whenever you're dealing with anything trigonometric, just make sure your calculator is in the right mode. In this case, we're talking in degrees. So make sure your calculator is in degrees. And yeah, 8.19, pretty good. Okay, go to number 5. Hold on. Get that off the screen. There we go. Number 5. If 4x plus 8 equals the square root of 94, then x plus 2 squared equals. Ah, I see a very nice way to do this problem. So, this is a trick. Whenever a problem is asking you to not just like find x, they're not just asking you to find x, they're asking you to find x plus 2 squared. Okay, so what you could do here is solve this equation for x, then take that x, add 2, and square it. That's a lot of steps. I would postulate that we don't have to do all that. And I see something immediately. Let's rewrite 4x plus 8 equals the square root of 94. Okay, hey, 4x plus 8 is the same as 4 times x plus 2. And I see that because that is so useful. That x plus 2 is in our answer, so we're going to keep that x plus 2. Equals, well, we didn't change anything on the left side. We just factored it. So equals the square root of 94. Why don't we square both sides? Because we need x plus 2 squared. So let's just apply a big square to both sides. It's not too hard to square the square root of 94. So 4 squared, when we square 4 times x plus 2, we're squaring a product of two things. That means that we need to square the 4 and the x plus 2. So this is going to be 16 x plus 2 squared equals 94. The square root of 94 squared is 94. Okay, we're looking for x plus 2 squared. So if we divide 16, we cancel the 16s. And 94 divided by 16, just whatever, break out a calculator. 94 divided by 16 is 5.875, which rounds to 5.88, which means I think the answer to number 5 is C. We get about 5.875 there. Yeah, I think that's pretty fast. I think that's pretty good. That's the thing that you want to notice here. Now, you might be thinking like, oh, that's hard notice for me. Totally get it. The sum of all of these little changes in the way that you go about these problems will save you time. If you start to at least just look for these little things like, hey, 4x plus 8, that can be 4 times x plus 2. Just look for those little things. You'll start to see them more, and you'll be able to solve some of these problems faster. All right, let's go to number 6. Number 6. If x is greater than 0 and y is less than 0, x is positive, y is negative, then x times y plus y can be which of the following? It can be which of the following. So essentially, which ones can't it be? You have 3 different possibilities: positive, 0, or negative. Okay, so if x is greater than 0 and y is less than 0, what can't this be? Well, if x is positive and y is negative, then xy is negative. Then we are adding y is negative. So this is a negative plus a negative. So I don't care what x was or what y was. This is going to be a negative plus a negative, which is just a negative. So your final answer has to be negative. Yeah, your final answer has to be negative. So it definitely can't be positive. It's definitely not greater than 0. The question is, could it be equal to 0? And I'm going to circle C because I know it can be negative, because my reasoning here does not allow for it to be 0. If x is greater than 0 and y is less than 0, there are no less than or equal to's or greater than or equal to's. These are strict inequalities. So x times y, if one is positive, the other is negative, this has to be negative. Cannot be 0. Y has to be negative. Cannot be 0. So we are taking two negative numbers and adding them together, which is making a negative number. This number is guaranteed to be negative. I am very positive in that answer. I'm very confident in that answer. Okay, so 6 is C. 7. The figure, we need the figure above. Okay, oh, well, looks like a V. The figure above is the graph of which of the following? Now, whenever you see a V, whenever you see that V, that is an absolute value graph. Okay, well, that doesn't really help us. All the answer choices have absolute value in them. So, if the figure of is the graph of which of the following? Okay, well, it is an absolute value function shifted 2 units to the left, 2 units to the left, and 1 unit down. All right. So with every type of function, whether it is linear, quadratic, any polynomial function, sinusoidal of any kind, logarithmic, exponential, I don't care. If you have a number like after the interesting part, so in this case the interesting part is the absolute value. If the interesting part was an exponential or logarithmic or whatever, if whatever comes after the interesting part is always like the y-intercept. Okay, so these all represent y-intercepts. This is, well, sorry, I shouldn't say that in, well, sorry, that's not, they don't always represent y-intercepts. They represent y vertical displacement. Okay, so they represent how far they go up or down. So whatever numbers are over here represent how far the function goes up or down when they're in these really nice forms. Okay, when they're in these standard forms. So, okay, we see that this function was shifted 1 down. That means that we're looking for functions that have a -1 on the end of them. Okay, and I'm saying this in the most general way that I can, because this is true for every type of function in its standard form. Okay, so this one would be shifted 2 units down, 2 units up, 2 units down. No, so the ones only with the vertical displacement of 1 unit down are the ones that we need to consider. So it's either A or E, just based off of that. Okay, is it x minus 2 or x plus 2? So sort of inside the interesting part, what is, in this case the interesting part is the absolute value. What's almost always true is it's like the opposite of what you might think. So x plus 2 shifts it 2 to the left. X minus 2 shifts it 2 to the right. If you think about what that's actually doing, it might make some more sense. But for now, if you want to just sort of memorize that inside of the interesting part, so if you put like, you know, a quadratic in your vertex form, and let's say you have like y equals x plus 2 squared minus 4, and where a is 1, whatever. So then we know that this graph is shifted 2 to the left, because the vertex form in general looks like x minus h squared plus k. So it's like we're subtracting away whatever that horizontal displacement is. In this case, we are subtracting a -2 inside the absolute value, since we are shifted 2 to the left, and that gives us an answer V. Long-winded way, you could look at this and know this answer immediately, as long as you know that general formula for a, as long as you're aware of how these general formulas for these functions work, which you should be. Okay, so 7 was E, now we're on 8. We can get 2 problems on the screen. Nice. If f of x equals sine x, g of x equals cos x, and h is the difference between sine and cos, what is the value of h at pi over 5? We have a calculator. I can figure out h at pi over 5, which using the calculator. And why wouldn't I do this? Clearly we're in radians, so we just have to switch to radians. Well, I mean, with a calculator, all this is sine at pi over 5 minus cos at pi over 5. So let's just do this on a calculator just to kind of see how quick it is. Maybe you have to switch calculator to radians. Then you do sine at pi over 5 minus cos at pi over 5. And I get an answer of B here, and that is the right answer. You could circle it and move on. Oh, I didn't have to scroll the screen, did I? Well, I did anyway. In the xy plane, the graphs of y equals 2 to the x and y equals x squared minus 7x plus 19 intersect at the point RS. What is the value of R? Okay, so, well, points where they intersect are going to be points where the two graphs are equal to one another. So we're looking at 2 to the x equals x squared minus 10x plus 19. If you have to, so okay, again, calculator. We can graph these two. If you have a sufficient graphing calculator, you can graph these two and figure out their point of intersection. I'm looking at this like, yeah, that's going to be a pretty good way to do this. What you can also do is just use the fact that you know that the answer is one of these five and plug some stuff in and figure out. Again, you're using your calculator. So yeah, I mean, I'll not do it with the graphing calculator way. So I'll just do. Okay, so let's start with. Well, 2 to the 5th is 32. 5 squared minus 50 is negative 25. So that's negative. So it's not 5. So we'll try, I don't know, 1.886. So we do 2 to the 1.886th power and 1.886 squared minus 10 times 1.886 plus 19. That gets us something very close. Very, very close. It's not exact. It's 3... Oof. Ooh, okay. It's very, very close. Let's try out 1.877. So same two things. 1.877. So plug all that in, and you get three things that are much more significantly different. So right when I tried D, I just picked D kind of randomly. I thought maybe it's D because 5 was like way off. So A was way off. So I was like, all right, maybe it's not even in the 3 range. Maybe it's around 1 to 2. So I just picked D. And D was very, very close. Out to 3 decimal places, this is very close. The actual answer to this is probably irrational. Certainly irrational? Maybe certainly irrational. Certainly irrational. So the actual answer is going to have a lot of decimal places, to say the least. So I tried D, and I thought, hey, this is really, really close. Really close. Almost. And then I tried E, and it was not as close. Somewhat close, but not as close. So therefore, D is the best answer given these 5. Yeah, and that's going to be... I mean, you could also probably just use your graphing calculator if you'd like and find the point of intersection. That would be fine too. All right, number 10. Yeah, so 9 was D. Number 10, when a service call by Johnson's Repair Shop takes more than 1 hour, the labor cost for the service call is modeled by that function, where... Okay, what is the labor cost for a service call that takes 2.75 hours? Why would I not just plug in 2.75 hours? What's up with this bracket parentheses business? Yeah, is there a reason why I can't just plug in 2.75 for T? I mean, you could rethink about f of T as 55 plus 40 times T minus 1, where T is now 2.75, so that's 40. So it's in your calculator. You don't even need a calculator. You would do 40 times 1.75, which is 55 plus 70, which is 125, which is B. Yeah, maybe a calculator might be faster, but either way, I think this is what you're looking for. There's nothing to this. It's a paragraph, right? It takes a while to read, and whenever you see a paragraph on these Math 2 subject tests, you kind of get scared because often these paragraphs have some confusing stuff in them. This one just just doesn't really have anything confusing. Just seeing how long the recording's been going on for. Okay. Yeah, this one's just okay. Yeah. Don't be afraid when you see a paragraph. Try not to. I'm still afraid when I see paragraphs, but try not to be afraid. Okay, number 11. If f of x is x squared plus 1 and g of x is 2x minus 5, then f of g of 2x. Ooh, that's a little ugly. All right, f of g of 2x. Let's figure it out. So g of 2x is 4x minus 5. G of 2x, you just plug in anywhere you see an x, you're now plugging in a 2x. So g of 2x is 4x minus 5. We're now taking f of 4x minus 5, which is 4x minus 5 squared plus 1. Oh, look at that. None of these answers choices quite match this. Looks like we're going to have to FOIL that one out. So this becomes 16x squared. Oh, hold up. D is the only answer choice that has a 16x squared at the front, and this has to have a 16x squared at the front. So whatever else, lower order terms, whatever else comes after this, meaningless, because this is the only answer choice that fits. So 11 is D. 12. Again, I didn't have to scroll. If the point negative 1/2 1 is on the graph of that in the xy plane, what is the value of A? Point negative 1/2 is on the graph of that. Okay. So by that first statement, we know that 1 must equal A times negative 1/2 minus 3, so negative 3.5 squared plus 50. So 1 minus 50, negative 49 divided by negative 3.5 squared. That's A. So we're looking for the value of A. We use a calculator. Yeah. Negative 49 divided by 3.5 squared. You don't have to mess around with the parentheses because negative 3.5 squared is the same as 3.5 squared. So just plug in 3.5 squared. And you have A as negative 4. Very good. All right. If x is non-zero, this is 13, by the way. If x is non-zero, then x to the 2 minus r over x squared. If x is non-zero. All right, so interesting. So some exponent rules problems. Take a quick drink while you guys digest this one. So x to the 2 minus r over x squared. Interesting. So x to the 2 minus r can be rewritten as x squared and x to the negative r. It's by one of the standard exponent rules that says x to the a plus b equals x to the a, x to the b. So we know this. And this is divided by x squared. So the x squareds are going to cancel, leaving you with just x to the minus r. Another way to write x to the minus r is 1 over x to the positive r. Sorry about that. Making our answer B. Yeah, anytime you see addition or subtraction in a exponent, in an exponent, you want to use your exponent rules to simplify those a little bit. Nice. 14. Which of the following is an equation of the line that contains the point negative 1, 4 and is perpendicular to the line with equation? Okay, this is like a standard pre-algebra, algebra 1 problem. They're asking you for the formula for a line that contains the point negative 1, 4 and it's perpendicular to the line with this equation. So perpendicular to this equation means that the slope has to be the opposite reciprocal of the slope that you see. which means that the slope m has to be 2/3 in our answer. Now, fortunately, you don't even have to know that, because all of the answer choices have 2/3 as their slope. So now, which of these contain the point -1, 4? I don't think you have to do much work here. I really, really don't think you have to do much work here. So back to what I said before. All of these functions, when you write it in a certain form, you could see the horizontal and vertical displacement. For a linear function, that vertex form looks like y equals the slope m times x minus h, where h is the horizontal displacement, plus k, where k is the vertical displacement. How come? Oh, so E fits this. So we know that by the way that they've written this formula, we know that this one contains -1, 4. Yeah, pretty sure. That's just E. We could, if you weren't too sure about this, you could plug in x equals -1 and y equals 4 and see if you get a truth. So x equals -1 gives you 0, so this whole term goes away, and you're left with 4 equals 4. So that would be good. You'd be good to go. 15. Oh, interesting. Data set, data? Tell me in the comments, do you say data or data? Data set B is formed by adding 5 to each of the numbers in data set A. Which of the following statistics is the same for data sets A and B? Ooh, this is just, do you know when you transform all the individual parts of a data set, all the individual elements in your data set, what remains constant? What is invariant in that transformation? Well, I think we can rule some out here. Maximum. If we're adding 5 to each of the numbers, then the maximum, whatever it was before, is going to be +5 in the new one, so it can't be that. Median. If we're adding 5 to everything, that means the median is going to have 5 added to it as well. Those are just numbers. Mode. If we're adding 5 to the mode, then whatever it was before, again, it's just a number. It's just going to be 5 more. So I think that you could pretty reasonably come down to just mean and standard deviation. What happens to the mean? Well, in general, the mean is, so let's say you have a bunch of data points, x1, x2, all the way out to xn. Then, where there are n values here, then your mean is going to be x1 plus x2 plus blah 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 plus xn over n, right? If we add 5 to everything, well, then our data points are going to be x1 plus 5, x2 plus 5, yada yada yada, xn plus 5. N is still n. All of these are going to have 5 added to it, added to them. So our final equation here is going to be x1 plus 5 plus x2 plus 5 plus xn plus 5 over n, which is, so there are a lot of 5s here. How many 5s are there? N 5s. So it's 5n plus x1 plus x2 blah 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 plus xn over n. So this is our new mean. And if we simplify this a little bit, we get 5n, or not necessarily simplifying it, but splitting up the fraction, we get 5n over 5 plus this over n. Sorry, 5n over n. Let's get rid of that. 5n over n plus this over n, the x1 plus x2 over n. x1 plus x2 over n was the initial mean. Let's call that mu. So 5n over n plus n. The n's are going to cancel, leaving just 5 plus mu. And we've just proven, in case you were curious, that when you add 5 to every single number in a data set, everything is going to go up by 5. The maximum, the mean, the mode, the median, the minimum, all of these are going to go up by 5. We've just eliminated these four. It means our answer is standard deviation. Do you want to prove it? Let's see. Do I want to even try to prove it? So standard deviation, variance is the sum of the squared deviations. I'm trying to remember back to my statistics days. So standard deviation is the sum of the squared deviations from the mean. So sigma is we're not going to prove it right now. That's not the point of this. I might have to look up the formula for standard deviation. I haven't looked at it in a long time. Probably should, but we're going to just say the answer is E and move on. If you have questions about why the standard deviation doesn't change, maybe you want to see a mathematical proof, let me know in the comments and I can post one in the comments. Be happy to do that. Whoa, what does this say? A sequence is recursively defined as follows. B1 is 3. Bn is the previous number in sequence plus 2n minus 1. What are the first 5 terms of this sequence? Okay. So it appears that all we need to do is find the first 2. Assuming this is a 3. We just need to find the first 3. Now I'm betting right off the bat that this is... it's going to be either B or C because these are the only ones that stay the same with the first 2. But maybe it's not. Who knows? But we definitely don't have to find all 5. It appears that we only have to find a maximum of 3. So let's just find 3. So the first one, the first term in the sequence is 3, which means it can't be D or E. Now the second term in the sequence means that we take the, we have to take the first term and add twice whatever term in the sequence we're at minus 1. So B2 is B1 plus 2 times 2 minus 1. So B2 is 3 plus 4 minus 1 is 3, which is 6, which means that the second is 6, which means it can't be answer choice A. Now we take B2. B3 is B2, which is 6, plus twice 3 minus 1, which is 6 plus 5, which is 11, which means our answer is C. Yeah, very good. Faster way. I think noticing that the first 3 terms I think that's the fastest way. I don't see a much faster way to do that. Noticing that you only don't just go about finding the first 5 terms when you don't have to. Don't waste your time finding the 4th or the 5th. That's the key to save time on that problem. All right, this is number 17 because this was 16, right? This was 15, so 16, this is 17. We are on 17 here. Which of the following is the nth term? Oh! We need to use this. So, which of the following is the nth term of the sequence? So, B1 is 3, Bn... Okay, let me just reproduce it. So, B1 equals 3, Bn equals Bn minus 1, plus 2n minus 1, for all n greater than 1. This symbol right here, for anybody who doesn't know, means for all. It's literally an upside down capital A. Oh! That was a mistake. There we go. Meant to do that. Which of the following is the nth term of the sequence? Okay, so, well, we know since this problem What was this? This was 16. Since 16 gave us answer choice C, we know that the first terms are 3, 6, 11, 18, 27. Okay, so what describes this sequence? Let's see. Is it 3 times n? No, because then it wouldn't be 11. So it can't be A. Is it 3 times n plus 1? No, because then the first one would be 4. Is it, or would it? No, the first one would be 6. Yeah. Is it 3 to the n? No, because then the second one would be 9. Is it n squared plus 2? Let's see. Well, if n is 1, then the first term is 1 squared plus 2, which is 3. If n is 2, then the first term is 2 squared plus 2, which is 6. So that works. If n is 3, then we have 3 squared plus 2, which is 11. Oh, look at this. 4 squared plus 2, which is 18. 5 squared plus 2, which is 27. Very good. Yes, this is this one works. Circle it, move on to the next problem. There may be a more mathematical, formulaic way to determine an nth term formula. There actually is a way to determine an nth term formula based off of a formula defined in this way. But you don't have to worry about that. You will not have to do this. All you'll have to do is be able to look at which one of these fits the pattern. That's the key to this problem. And we move on to 18. Thank goodness we can see the numbers. Okay, 18. All of the following are equal, except... Oh boy. Okay, well let's figure out what some of these are. Log 10 100, what does that mean? This is the exponent on 10 that gives us 100. In other words, 10 to what exponent gives us 100? Well, the answer to that what is 2. So this one's 2. Okay, log 510, same idea. 5 to what exponent? We'll start calling them x. 5 to what exponent gives us 10? I don't know, something weird. So x is something weird. Who knows? It's log 510, whatever it is. It's weird. So first one is 2. The second one's weird. This one, 2 to what exponent gives us 4? Y, this one was x, y equals 2. Oh, okay. So A is the same as C. Stop right there. B is the right answer. All of the following are equal, except this one. Well, we know these two are equal, so as long as we're confident in these two answers, we can stop. We don't have to worry about D and E. If you wanted to go through this, you absolutely could. But there's no point. Let's look at 19. Which of the following functions has all real numbers for its domain? This is an hold on, is this a weird question? Because I mean, so I think at the beginning of let's use the mouse to scroll back to the beginning, because at the beginning I believe they say something. Let's just read what that is. Oh, look at this. It looks like popping off the page. Unless otherwise specified, the domain of any function is assumed to be the set of all real numbers for which f is a real number. The range is assumed to be the set of all numbers f of x where x is in the domain. Essentially, that's just the image. But yeah, we won't talk about the difference between image, range, pre-image, domain, codomain. There's a lot of nonsense there, but we don't worry about that. So which of the following functions has all real numbers for its domain? We're sort of assuming that based off of what we just read, we have to make these assumptions. Okay. Has all real numbers. Essentially what you're saying is, which of the following can I plug in any real number and obtain a real number? Well, for the first one, we can't plug in negatives. Therefore, the domain is, we can write, you can write it in a million different ways. We can say 0 to infinity. We can say all real numbers greater than or equal to 0. We can say, I've seen it as r plus together with the element 0. There's a whole bunch of different ways that we can write this, but the bottom line is the domain is not all real numbers. So the domain for the first one is, if you don't understand all that math craziness, it's just 0 to infinity. And that means that it's not all real numbers, so A is not the right answer. 1 over x squared. Is there anything we can't plug in? No 0. No 0. So that means it can't be B. Anything that we can't plug into this? Well, we can plug in positive numbers. Positive numbers to the fourth are well defined. Negative numbers to the fourth power are well defined. Dividing by 5 is fine. 0 to the fourth divided by 5 is all well defined. This looks good. This is going to be our answer, but we're going to keep going. We're going to explain why these two can't be. Absolute value of x divided by x minus 1. Can we plug in anything? Well, no, we have this denominator. And x minus 1 cannot be equal to 0. This implies that x cannot be equal to 1. So 1, which means that the domain is all real numbers except the elements. Wait, is it? Do you write it like this? No. All real numbers except the element 1. So this is not going to be sufficient. X plus 2, again, all real numbers where x cannot be negative 2. So these are not possible. It has to be C. C is the only one that admits all real numbers into its domain. All right, in the XYZ coordinate system, how many lines can, in the XYZ coordinate system, how many lines may be drawn perpendicular to a given line at a given point on the line? Okay, so if you have, it's very hard to draw in 3 dimensions on a 2-dimensional computer screen, but if you have a line and assume it is in 3 dimensions, so it is a line in 3 dimensions, and you pick a point on that line, how many lines may be drawn perpendicular to a given line? So, well, in 2 dimensions, you can only draw 1 line perpendicular. And perpendicular just means that you create a right angle. So there's your first perpendicular line. And there are no other lines that you can draw. Now, if you're in 3 dimensions, I think a lot of you may have thought the answer is B. Now, hold on. Let's pretend we're sort of in 3 dimensions here, so we'll try to draw this best we can. The way I've just drawn this line is what you're thinking of, like the 3-dimensional, 3 real axes, right? So you have maybe like your x-axis, your y-axis, and your z-axis coming off the page, sort of. In this way, these 3 lines are all orthogonal to one another. They're all perpendicular to everything. So the x-axis is perpendicular to the y-axis, the x-axis is perpendicular to the z-axis, the y is perpendicular to the z. They're all perpendicular to one another. This problem is not asking, it's an interesting problem, it's not asking for your lines to be orthogonal in every dimension. Okay, all they're asking is for them to be perpendicular to one line. So if you have that one line, how many ways can you make it perpendicular? Well, you could put it in one plane, right? You could put it, maybe it's the XY plane. You could put it in specifically the XY plane. Or imagine sort of, so you have your one line and you have your perpendicular line in the same horizontal, let's call it the XY plane. Imagine tilting into the third dimension, but not all the way to becoming the z-axis, just a little bit. This line is still orthogonal to that first line that you drew. It's still, orthogonal means perpendicular. It's the same words. It's just orthogonal is usually used when you have more than two dimensions. It can also be used in two dimensions. It's just a more common linear algebra term. So imagine sort of tilting this line in three dimensions. This would still be perpendicular. You got to think about it. It would still be perpendicular to the original drawn line. So this angle right here is still perpendicular, still 90 degrees. And imagine now that you can draw that angle however you want. There's a lot of angles to rotate this plane through. A lot of angles to rotate this line through. In this way, there are infinitely many different perpendicular lines that can be drawn given perpendicular to a point. Perpendicular to a given point. It's like I had all the right words there. They were just in the wrong order. That was kind of funny. Okay. So that's 20. That's E. Cool problem, I guess. 21. Uh-oh. Can we see it all? Yes. 21. The graph shown above has equation y equals 2 sine x. If the graph is shifted pi over 2 units to the right, okay, which of the following could be the equation of the shifted graph? So like I talked about before, we are doing a horizontal shift or horizontal displacement. That usually occurs inside the interesting part. In this case, the interesting part of our problem is this sort of sine piece. So horizontal and or vertical displacements occur inside the interesting parts. It's almost always true. But let's say you didn't notice that immediately, or you're not really sure of that. Then what you could notice is, let's take a look at A and B. A and B have these two shifts. These shifts are vertical shifts. Okay? When we add pi over 2, we're shifting it up pi over 2. When we subtract pi over 2, we're shifting the whole graph down pi over 2. So it's not A or B. Y equals pi sine x for answer choice C. Pi is the amplitude of your in this case, it is the amplitude of your function. So notice that with y equals 2 sine x, the amplitude is here 2. So it's like the height of the function is 2 units. So if it was pi, all that would happen is it would stretch to be pi units high as opposed to 2 units high. So that's not the right answer either. So it's not A, B, or C. Therefore, it's D or E. And it's whichever one is a 2-unit shift to the right. And we know that sort of you got to think of it as x minus the horizontal displacement. So with sine, it's sine of x minus h plus k for the vertical displacement. Notice they all look like this. Like I promise, they're almost all like this. So, and maybe a is the amplitude out front. So y equals 2 sine x minus pi over 2 is a shift of pi over 2 units to the right, making our answer E. So 21 is E. Very confident so far in everything. Could have gotten something wrong. I don't think so, though. Again, if I do get one wrong, I will go back and correct it. Let's use a different color. We're on number 20. What are we on? 21? 22. And we are an hour, just over an hour in. Nice. Which of the following inequalities must be true for all real numbers x? True for all real numbers x? Oh, well, I mean... well, these are all quadratics. Essentially, if we're saying that they're greater than 0 for all real numbers x, what they're asking is, which of these has a graph that never touches or goes below the x-axis? Okay, so x squared minus 2x. X squared minus 2x. If we take x squared minus 2x, we know this is x minus 2, which means that our roots are 0 and positive 2, which means that if we drew this, we know it has to... Sorry, thought I heard something. We know it has to intersect the x-axis at 0 and 2. So at the origin and 2. If that happens, it must dip below the x-axis. It's going to look something like this. Which means that 1 is false for all real numbers, because any number between 0 and 2, say 1, is going to break this inequality. So 1 squared minus 2 is negative. Can it be none? Yeah, we don't know if it can be none. So we know this one's false for all real numbers. So it can't be 1 and 2. Alright, let's look at number 2. Okay. 2 is going to break. It's going to be really interesting. Okay. X squared minus 2x plus 1. X squared minus 2x plus 1. This is x minus 1... x minus 1, which means our roots are 1 with multiplicity 2, if you want to be very, very particular about it. So 1 with multiplicity 2, okay, so that means it hits the x-axis at x equals 1, and it just touches it. Just like that. And that means that I assume if we plug in a 1, we're going to get equal to 0, therefore breaking this inequality based on what we just did over here. Okay, so 2 isn't true. So 2 is false. So that means it can't be this. Can't be this. X squared minus 2x plus 2. I don't even have to do anything. All this is going to do is shift up every point by 1. Meaning that this new function is this? Yeah. Meaning that this new function is going to be shifted up 1. It's going to look the same as the second one that we drew, shifted up 1. Therefore, it will never touch the x-axis or go below it, which means 3 is true, and 3 only is the answer. In this case, it's a little bit annoying. It does appear that you have to check a lot of these, but yeah. It's interesting. So with this problem, if there are real roots or even a single real root with multiplicity 2, then to any of these answer choices, then it must be a false answer choice. Yeah. Okay. If 2n divided by 6 is an integer, then which of the following must be an integer? 2n divided by 6 is an integer. So that means that when we multiply n by 2 and then divide n by 6, we get an integer. Okay. Another way we can write this is n over 3. 2n over 6 is equal in every situation to n divided by 3. That means that n divided by 3 is an integer. It also means that n is an integer. Uh, so, if n over 3 is an integer, does that directly imply that any of these are integers? Does that imply that n over 12 is an integer? No, because pretend that n was 1. If n equals 1, then n over... pretend that n is 3. If n is 3, then 3 divided by 3 is 1, but 3 divided by 12 is not an integer. N over 4, no, not at all. Pretend n was 3, then this is a counterexample. Then that's a counterexample. N over 2. No, because pretend n is 3. Still a counterexample. 3 divided by 2 is not an integer. Pretend n is 3. Still a counterexample to this one. This is 6/5. 1.2 is not an integer. 2n over 3. Yes, this is an integer. You should notice that much quicker than that, though. If n over 3 is an integer, then we can multiply that by 2, and it's still an integer. 2n over 3 is still an integer. This is the only one that's a multiple of our original, well, almost our original designation of an integer. So, that's why we get that. Cool. Sort of cool problem, I guess. A line segment is 10 units in length with one endpoint on the y-axis at the point 0, 6. Oh god, this is already sounding like something I'm going to want to draw. So a line segment is 10 units in length, one endpoint on the y-axis at the point 0, 6. Okay. So at the point 0, 6, here's our y-axis. This is 0, 6. It's 10 units in length. It doesn't tell us what direction it's in. So all we know is it's 10 units in length. It's a line segment, so this is the point 10, 6. Which of the following intervals represents all values of x for which the segment intersects the x-axis when the segment makes a complete rotation about 0, 6? So it goes all the way around, creates a circle. Ooh. Okay, and this circle has this length right here of 4. Radius of 10, this is 6, this is 4. So this is that line going all the way around. So what represents all values? Well, okay, so we don't need to know like the area of this part of the circle right here. We don't need to know that. What we need to know, though, it's going to be important to know where this point is. And hopefully you can see that this is, it's going to be symmetric. So where's this point as well? So we know it's symmetric. So it looks like the answer is going to be A or C. It's definitely not no such interval. And those are not symmetric about the y-axis. So it looks like it's going to be either that -8, +8, or -6, +6 inclusive. Well, okay, so we know this. We know this line right here. This line is the radius of the circle, and the radius of the circle is 10. Okay, so that means that we have a right triangle here with one side length, one leg of 6, and with the hypotenuse of 10. You should immediately notice, I really hope you notice this. 6 is 3 times 2. 10 is 5 times 2. We know about 3, 4, 5 right triangles, so this one has to be 4 times 2. This one has to be 8. So this length is 8. So that means this point is -8, 0. And this point symmetrically is 8, 0, making our answer the interval -8 to 8 inclusive. Yeah. You could have done that without doing this math. That's what I was thinking about a little bit. You could have done without, you didn't have to. Absolutely didn't have to. If this one is 6, if this length right here is 6, right here, then this can't be 6, just by the way a circle works. If it was, then the radius of the circle would have to be here, if that makes sense, not here. Yeah, it doesn't make sense geometrically. So the answer had to be A. 25. When we finish this, we're halfway done. A set of 12 numbers has an arithmetic mean of 20. Okay. If the numbers 10 and 14 are removed from the set, what is the arithmetic mean of the 10 numbers remaining? Ooh. Okay, let's just use what we're given. A set of 12 numbers has an arithmetic mean of 20. So let's go x1. Let's say x1, x2, dot, 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 xn. No, x12 are 12 numbers. Actually, no. x10, and then we have the number 10 and the number 14 are removed from the set. Okay. And we know that the sum x1 plus x2 plus all the way out to, I keep writing n, all the way out to x10 plus 10 plus 14 divided by 12 has to equal 20. Okay, so what is x1 plus x2? So then, okay, so let's rewrite this a little bit. This can be x1 plus x10 over 12. This is still equal to 20. Plus, let's add 10 and 14, get 24 over 12, plus 2 has to equal 20. Which means that if we subtract 2 from both sides of this equation, we get 18 equals x1 plus dot 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 plus x10 over 12. So we've figured out something, but this isn't. Be careful here. The answer is not 18 because this is not the arithmetic mean. The arithmetic mean needs to be over 10. Not over 12. So we need to essentially just multiply this by 10 and divide it, multiply it by 20 and multiply it by 12 and divide it by 10. So when you multiply 18 by 12 and divide it by 10, you're essentially multiplying it by 1.2. You can use a calculator. 18 times 1.2 gives us 21.6. So we're doing the same thing to both sides. Multiplied by 12 divided by 10 gives you 21.6. Faster way to do this. Is that even the right answer? Has to be. I think so. Is there a faster way? I don't immediately see it. If there is a faster way, I don't immediately see it. They have an arithmetic mean of 20, and you remove 10 and 14. I suppose you could do a lot of this in your head to be faster, but you don't have to, like, I'm writing out this sum thing, like, every time. This takes a while. Like, you don't want to waste time writing out this sum every time. I mean, if you want to use summation notation, this might be even longer. Maybe it'd be 12 or 10 of K's. That might be even longer. So... yeah, I don't know of a faster way. I just noticed what I had to do, and I did it. It's probably the best you can ask for. Okay, number 26. Number 26. In the figure above, a cable 40 feet long is attached to a vertical pole. It's the nearest foot. How far from the base of the pole is the cable attached to the ground? Okay, so what they're essentially asking for is this. They're asking for X. We'll call this P for pole. It's a right triangle. So, I mean, notice that we know all angles in the triangle. This one has to be 40 because the sum of these two have to be 90 because the sum of all three have to be 180. And you know this is 90. So, in a right triangle, the two other angles have to add to 90. Okay. I mean, we could just use our trigonometric identities. I think we know that the cos of 50 degrees has to equal adjacent over hypotenuse. In this case, the adjacent is what we're looking for, and the hypotenuse is 40. So then 40 cos 50 is our answer. And make sure your calculator's in degrees. And go about doing 40 cos 50. 25.71. Which means I'm going to guess that the answer is A. Well, it's more than a guess. But very good. Faster way to do this. Oh, you know, there might be. There absolutely might be. Is it faster, though? I don't know if it's faster, but let's say this was a slightly different triangle. Let's say it was a 45 triangle. What that would mean is that the cable is further out. So this is going to be, if this was X, this is going to be bigger than X. Whatever this length is here, we'll say it's Y on this triangle. It's going to be bigger than X. If this is still 40, and this is a 45, 45, 90 triangle, that means that this Y is 40 divided by root 2. Or 40 root 2 over 2, or 20 root 2, or approximately, again, this is all now in my head, 20 times the square root of 2 is about 1.4, so 20 times 1.4, for about, which is 20. What is this helping? Just it's 28. Yeah, of course this helps. So, okay, so that would mean if this was a 45, 45, 90 triangle, then Y would be 28 feet, approximately. This is approximately equal to 28 feet. If it's a bigger angle here, then X has to be smaller than 28 feet. Meaning you could immediately circle A. If you do this really quickly, somehow faster than you could plug in 40 cos 50 into your calculator, then maybe you could notice this was A without a calculator. Again, your calculator breaks mid-test. You could still do this problem. It's good to know. Just hope your calculators don't break mid-test, because that would be bad. I wouldn't wish that on my worst enemy. Okay, so we got a function. It's defined for the table above, defined by the table above. For which of the following values of x does f of x equal 6? Okay, so we're looking for values of f that give us 6. We're looking for values that we can plug in that give us 6. So that's 3. So we know that, take a look at this, f of 3 equals 6. Okay, so now when does f of x equal 3? Because then we'll be able to plug that in for our f of x. When does f of x equal 3? Well, that's at 2. So that means that f of 2 equals 3. And f of 3 equals 6. So f of 2 has to equal 6. Which means that our answer is 2, B. Sure. 28. I had somebody ask me about 28. I didn't really think about it too much, but let's see if I can explain this one. I just read the problem. So in the last video that I made, somebody asked me about 28 on this specific test, and I read the problem, thought I had an idea of how to do it, but I never really actually put it to fruition. So let's try this one. This one's for you. In a plane, what is the set or locus of all points equidistant from two intersecting lines in that plane? All right, so we need two intersecting lines in a plane. We'll say that the plane is the page. We don't have to draw the plane. So we need two intersecting lines. Let's say one of those lines is like this. They're intersecting. They don't have to be intersecting at a right angle. They just have to be intersecting. All right, we'll do that. So two intersecting lines. What is the locus of all points that are equidistant from those two lines? Okay. So our answer options are just a line, two perpendicular lines, two parallel lines, 4 points, or none of those. Well, okay. So I can put, so this point right here, it is this far away from there, we'll say this is line L and line M. It's this far away from line L and equally that far away from line M. So this point would be in our set. We'll say the set is A. This point would be in the set A. So would this point, though. Like this. So would this point. Like this. So would points up here. Like this. So would points down here. This is starting to look a little bit like a DNA molecule? Yeah. This is not the biology subject test. So would all these points. So clearly it's not none. Clearly it's not 4, I would say. So there's a lot. What this is going to create is a line. Like this. I'm going to try to draw that a little bit better. It's going to create a line that goes through the intersection point, because the intersection point is sort of also trivially another one of these points. The intersection point of L and M. So one of our lines, we'll call this, I don't know, line X, is going to go through that intersection point, and it's gonna like split the lines L and M. Okay, is that all? Well, no. What if we sort of take it from the other way? What about this point? This point is about this far away. Assuming I, drew this well enough. This point is about this far away, right? This point, just like this. And we could keep drawing points out like this. Similarly on the other side. And we'd get a line like that. Call this line Y. Okay, so now we know it's not just a single line. These lines are definitely not parallel. So I would say, without proving it right now, a picture is not a proof. A drawing is not a proof. So without proving it, these are, B is the only leftover answer choice. But these lines would be perpendicular. Can we see that? Well, yeah. Well, without... Is it easy? I don't know. There's no need to prove it right now. Given that there's the 5 answer choices, we have 2 lines, and hey, they're calling them perpendicular, so take your word for it. I think I kind of see why they'd be perpendicular. Yeah, I do see it, but it's not worth going into. Hopefully this drawing helps you and makes sense. But yeah, I think the answer is B. 29. Okay, so 30 cards are numbered from 1 to 30. Brilliant. If one card is drawn at random, what is the probability that the number on the card will be divisible by either 3 or 5? Okay, let's list out numbers between 1 and 30 that are divisible by 3 or 5. Well, we have 3, 6, 9, 12, by either 3 or 5. So I'm just going with divisible by 3. 3, 6, 9, 12, 15, 18, 21, 4, 27, and 30. So we have 5, 10. There's 10 numbers here. Now, are there any multiples of 5 that are missing? Because we can also do multiples of 5. Yeah, we need 5, 10, 15 is already there, 20, 25, and 30 is already there. So we're adding 4 more. We're adding 5, 10, 20, and 25. So it appears that we have 10 plus 4, 14 different numbers that are divisible by either 3 or 4. Some of them by both, but either 3 or 4. So 14 over 30 is our answer, which is 7/15. I assume that is one of the answer choices, and it is. Beautiful. Faster way to do that? No. I don't think so. I think just if you get right to this, get right to listing out your factors of 3 or your factors of 5, whichever one. You do this pretty quickly. I don't think it's worth trying to save time. I don't even know how you would think about saving time, but yeah, let me know in the comments, of course, for any of these where time saves are possible and I'm just not seeing them. Time saves like it's a speed run or something. If f of x equals x plus 3, x minus 1, and g of x equals 1 over x plus 4, it is. We are on an hour and a half. Cool. F of x is that, g of x is that. What are all values of x for which g of f of x is undefined? Let's make g of f of x. So g of f of x is we plug in f of x into g of x, so it is x plus 3, x minus 1 over x plus 4. This is g of f of x. Hopefully composition of functions is something you're all very good at. What are all values of x for which this is undefined? X plus 3, x minus 1 over x minus 4. So our answer choices are all sets, and they're very small sets. Is -1 undefined? Why would it be? Oh, I am doing this problem completely wrong. I was like, whoa, jeez, let's just get rid of that, pretend that never happened. So f of g of x is not what I just wrote. I just did like f of x times g of x. Speaking of people who don't know how to do composition of functions. So g of f of x is 1 over that's weird. X plus 3, x minus 1, plus 4. Okay. Okay, so now, what is going to make this undefined? Essentially what this is asking is, when is x plus 3, x minus 1, plus 4 equal to 0? Because wherever it is equal to 0, we have a problem. Okay, we can do this out, I guess. X squared plus 3x minus 3 plus 4 equals 0. So this is x, I don't know why I did it like this, x squared plus 2x plus 1. Equals 0. That's x plus 1, x plus 1 equals 0. Which means that -1 is a root of this, which means that if x equals -1, let's just verify that. -1 plus 3 is 2, -1 minus 1 is -2, -4 plus 4 is 0. Yes. So x equals -1 is the only root. A is your answer. Right? It can't... Okay, I could see why this problem would trip some people up. That is, I mean, assuming you don't do the thing I did at the beginning, even still, you could see this 4 and assume that, like, -4 has to be, and then, like, it must be even. But you got to be careful. -4 isn't a 0 here, so yeah. In a circle, if a circle with center RQ in the second quadrant is tangent to the x and y axes, then in terms of Q, what does R equal? Let's draw it. This is screaming for a drawing. So let's draw our x and y axes. Remember, if you're doing this on the test, you don't have to be as particular with your drawing, but I'm trying to just be clear. It has center R and Q, so it's tangent to the x and y axes. And the center is in the second quadrant, so the second quadrant is over here. So its center, let's put its center. Its center is somewhere like right here. And this is the point. The negatives are going to be weird. This is the point RQ. It is tangent to both the x and y axes. Okay, I didn't take that into account. If it's tangent to one, that means that the circle has to have a radius like that. But then it's not tangent to the other. Okay. So that means our point... Ooh, that's really cool. So just by drawing it, hopefully it's obvious. Hopefully you can tell that since it has to be tangent to both, it has to be R and Q in absolute value have to be equal. Now in reality, we know R is negative and Q is positive. So that means R equals negative Q. R equals negative Q. That's a cool problem. That's a cool problem. Hopefully it makes sense the way I explained it. If you try to draw it, I mean, try to draw it. That's the key. With so many of these problems, just try to draw it. Interesting problem. In the figure above, if y equals 140 degrees, what is the measure of angle B to the nearest degree? Okay, so y is 140. What is the measure of angle B? Well, if... Oh. Okay. I mean, are we just going to do some law of sines? So we're looking for this angle. We'll call it theta. So... yeah, I guess we're just going to do law of sines. So you got to know your law of sines. I don't think this is going to be... I'll look after to see if there's a faster way. Sine of theta over 15 has to be equal to the sine of 140 over 20. They're in ratios, so this is 3/4. So... $105. Wait, no. The sine of 140. I'm trying to see if just by writing this, can you tell what the answer is? I don't know. I'm not sure. 15 sine 140. Just through cross multiplication, we'll just write out all the steps. 20 sine theta. So 15 sine 140 over 20 equals sine theta. Is this going to give us an ambiguous case? So then the answer is, of course, arc sine 15 sine 140 over 20 by just taking the arc sine of both sides. Let's try it. So let's do 15 sine 140. 9.6 approximate. Am I in the right mode? Of course I am. And then we're going to take the arc sine of that value. Right. Oh, whoops. 15 sine 140 divided by 20. Forgot to do that. Arc sine of that value gives us 29. About 29 degrees. It's very close to 30, but it is 29. And yeah, I guess as long as you do it that way, you're not going to run into any issues. I don't know. I don't have to think more about if it's an ambiguous case situation, but I think we're good. Just doing it that way, we're okay. Okay. So 33. If f is a function that satisfies f of 3x, if f is a function that satisfies when we plug in 3x plus 2, we get x for all x, then f of x is the inverse. How do I, so f of x is the inverse of 3x plus 2, which is x minus 2 over 3. I see this and I immediately know the answer is e. Let's talk about this for a second. Let's talk about why I know the answer is E without doing anything. Okay. In general, very generally, let's say you have one function f and another function g. If you know that f of g of x is equal to x, then this implies, it's actually a double implication, that f is the inverse of g. So essentially this means that if you it's sort of like, you know, think about it like with e to the x, the exponential function, and the logarithmic function. If you do e to the ln of x, you get x, because e and ln are inverses of one another. Just the same, if you do 1/2 x and 2x, those are inverses of one another. You do 1/2 of 2x, you get x. This is a like a maybe a theorem of mathematics right there, or would you call it a definition? I guess it's a theorem. That's a theorem. So regardless, it's a mathematical fact. Oops. So this is a mathematical fact. Okay, so now let's look at this problem. We have f of 3x plus 2. F of 3x plus 2. So pretend this 3x plus 2 is sort of like our g of x, because f of 3x plus 2 is giving us x. So this is our g of x, and it's giving us x. So f must be the inverse of g of x, essentially because this is a double implication. It's an if and only if statement. So f must be the inverse of 3x plus 2. So how do you find the inverse of 3x plus 2? Well, you set 3x plus 2 equal to some other variable, maybe y, and you solve for x. So y over 2 is equal to 3x, and therefore x equals y minus 2 divided by 3, which means if we just sort of transmute these variables, we have y equals x minus 2 over 3, and this y is now f of x, which we also know is g prime, not g prime, g inverse of x. G prime would be the derivative, not that. Yeah. That's kind of cool. That is being efficient with your problem solving. That's 33. 34. Ooh, should I show if, let's say, you didn't notice that? Is there a way without noticing it? Yeah. You could just plug stuff in. So plug 3x plus 2 into all of these. That would be pretty quick. Plug 3x plus 2 into all of these, and one of them will give you x. And that's going to be the right one. In the figure above. Oh boy. Uh-oh. Okay, so back in here, I have looked up what the figure is for this problem. I found it in another Reddit thread, and I recreated it here in front of you guys. This is still number 34. This is the correct drawing. So we have an angle theta here that starts at the positive x-axis and goes all the way around to this line, to this hypotenuse for this triangle at -3, -5. So this is point P, point O, and OP passes through the point -3, 5. So this is what you can glean off of that. Okay, so now we're looking for the measure of angle theta. All right, so if we I have still haven't done the problem. If we find this angle, let's call it x, then we know that 270 degrees theta is 270 degrees minus x. Seems pretty solid to me. We know that x has to be bigger than 180 degrees, so I'm just going to cross off a. Just make myself feel a little bit better. It can't be that. Let's recreate this triangle as well. Let's draw this triangle. We know that this length here is 3. This is 5. Be careful, this isn't a 3, 4, 5 right triangle, unfortunately. And this one is unknown. We know that, so the x is the angle up here. Maybe we'll call this h for hypotenuse. And if we find x, we know theta. So x, or I should say the tangent at x is opposite over adjacent, so 3 over 5. 3 over 5. Yeah. So tan x is 3 over 5, so arctan of both sides equals arctan 3/5. This is x equals arctan 3 over 5. So if we do that with our calculator, make sure, oh, it doesn't, well, yeah, well, so arctan 3 over 5 gives us an angle. You can be in radians or degrees. It's just going to give it to you in radians or degrees. I would prefer to look at this in degrees. So the degree measure of that angle is 30.96. We do 270 minus that answer, 239, which means our answer is E. 270 being the whole way around, 3/4 of the plane, and then minus away whatever that x was, since we found out that the x was 30.96, then there we go. Yeah, hopefully that makes sense. Yay! So we're on to 35. What do we have, like 16 more problems then? 5, 6, 7, 8, 9, 10. And then 10 more, yeah, 16 more problems. Okay. Whew, 35. If the frequency of a periodic function is defined, almost 2 hours. Frequency of a periodic function is defined as the reciprocal of the period. Cool. What is the frequency of f of x equals 4 sine 2x minus 1? Well, what's the period of 4 sine 2x minus 1? That is the question that you need to ask. So let's draw this. I was thinking about a way that I can explain it without drawing it, but let's just draw it. So for a regular sine function, if you plug in the sine of if you just have sine x, then it's just going to look like this. A little hard to draw, but yeah. And then it goes off in that direction too. So the period here is 2 pi. Period is, how long does it take to, that's a little bit off. How long does it take to change, or to repeat itself? Okay, so 2x minus 1, that's not a regular sine wave. Well, it is a sine wave, but it's not an extremely standard sine wave. So the minus 1, well, the minus 1 is not going to matter. You think about what you plug into sine. You plug in degree measures. Yeah, you plug in degree measures or radian measures. So if you just take away 1, like the sine of x minus 1, whether that 1 is degrees or radians doesn't matter, the sine of x minus 1 is still going to have a period of 2 pi. The sine of x minus 2 will still have a period of 2 pi. The sine of x minus 90 degrees, or x minus pi over 2, or x minus 2 pi, will still have a period of 2 pi, or 360 degrees. So this part doesn't matter. It's just the 2x. What does 2x do? If you think about it, that means that it's going to make the sine wave go faster. So if I plug in, say, let's say I'm thinking in radians. So if I plug in pi over 4, I get 2 times pi over 4, which is pi over 2. So when x is pi over 4, the sine is the sine of pi over 2. And we know the sine at pi over 2 is 1. So we've already gone from 0 to 1 in the space of pi over 4. In the space of pi over 2, we're going all the way to the sine at pi, which is 0 again. So in the space of pi over 2, we're doing this. I could draw that better. In the space of pi over 2, we're going all the way up and back. So if it didn't make like logical sense to you why 2x has a smaller period, hopefully this is helping. So another pi over 2 is going to bring us along the negative side of the sine curve. And this is one full sine wave right here. This is going to keep going that way, keep going that way. This is one full sine wave. So that means the period is pi from there to there. Oh. So that's why the period is sort of, you know, if you have the sine of ax, then its period is 2 pi divided by a. In this case, 2 pi divided by 2. Okay, so then the frequency is the reciprocal of the period. So in this case, if our period is pi, the frequency is 1 over pi, making 35b. Okay, the volume of a certain right circular cylinder is 16. Okay, I'm going to draw that. We have a right circular cylinder. I don't like how I've drawn that. Let's make the top a full circle. Like this. And there's our right circular cylinder. So it means it's not on any sort of angle. It's a normal circular cylinder. The volume is 16 of this circular cylinder. A larger right circular cylinder has a radius that's 25% greater and a height that's 50% greater than the radius and height of the smaller cylinder. Okay, so we have a larger cylinder. Let's... What? Larger cylinder. I don't know. I'm not using the exact... I'm not trying to think about the exact dimensions here, but essentially, we're looking for the volume of the larger cylinder. The radius is 25% greater and the height is 50% greater. So let's say that the volume of this one is pi r squared height, right? So we're here, we have the r and h. We know that this r right here is 25% greater. That means that it's 1.25 r. And this h is not h anymore, it's 1.5 h. So the volume of this guy, we'll call this, well, we know this volume was 16, so we'll call this V1 and V2. V1 was 16, so just for the sake of clarity, 16 was pi r squared h. V2 is pi 1.25 r 1.5 h, and the r is squared. So now we figure out oh, okay, so let's make this easy. V squared, V2 equals pi, and then we have 1.25 squared r squared. I'm just going to pull the squareds out here. And then we have 1.5 squared h. Oh, nope. 1.5 h. I can rearrange some terms. Pi r squared h, 1.25 squared times 1.5. And this is V2. And then we can do a little more here. V2 equals pi r squared h, that's V1. That's 16. 16, 1.25 squared times 1.5. Calculator time. 16 times 1.25 squared times 1.5 is 37.5. That is my final answer. That's all she wrote. 37. If f of x is that, what number does f of x approach as x approaches to? This is a limit problem in disguise. If you haven't seen limits, that's okay. So this x squared plus x minus 6 over x minus 2, this is the same as, what is this, x plus 3, x minus 2 over x minus 2, which means we can cancel these, assuming x isn't 0, assuming x isn't 2. We're asking about when x approaches 2. So we don't care about what happens when x is 2, which means that we can eliminate x minus 2 as a factor, because we don't care when x is 2, so we don't care if the denominator's, we don't care about the only point where the denominator is 0. So this is the same as x plus 3, which means as x approaches 2, this is 2 plus 3, which is 5. And that's why our answer is going to be D for 37. This is the same problem as the limit as x approaches 2. If you are familiar with this, which you may not be, and that's okay if you're not, x squared plus x minus 6 over x minus 2. And you would do the same work. Yeah. This is something you'll see in pre-calculus, and then you're going to study it more at the beginning of calculus, because it's the formulation for the derivative. Requires limits. 38. Oh, I love problems like this. An operation triangle is defined on the real numbers x and y by the equation x triangle y is the absolute value of x minus y squared, which is the following is true for all real numbers x and y. So so if you do get confused by something like this, mess around with this new operation. So let's mess around with triangle. Well, what I would say here is, so if you do get confused, mess around with triangle. That's true. Let's say that we're not confused though. What would I do? I would just look at A and see if it's true. Then look at B, see if it's true. C, D, E, see if it's true. So X triangle y. Is it equal to y triangle x? This is actually the same as asking, is triangle commutative? Well, let's see. X triangle y is x, the absolute value of x minus y squared. Y triangle x is equal to the absolute value of y minus x squared. That does not equal the absolute value of x minus y squared, which is x triangle y. In general, this is absolutely not true, so it is not a commutative operation. Okay, let's look at this. Let's look at the second one. What is this asking? I don't know. There's not really a word for that as far as I know. Okay, so x triangle y, negative x triangle y. So we know x triangle y is the absolute value of x minus the square of y. Negative x triangle y is the absolute value of negative x minus y squared. Hopefully you're seeing something. The absolute value of negative x minus y squared, the absolute value of negative x, well, if x is positive, then x triangle y is so technically we should separate this into two cases. I'm going to talk about these cases. When x is positive, then x triangle y is x minus y squared, because the absolute value doesn't do anything. It's the same. When x is negative, then x triangle y is negative x minus y squared. Okay? So when x is positive, the absolute value of x is the same, and when x is negative, the absolute value of x is whatever the opposite of x is, which is the opposite of a negative number, which is a positive number. Okay, when x is positive, negative x is negative, right? So then the absolute value of negative x is the opposite of this, which means this is positive. So this is positive x minus y squared. So when x is positive, this is x minus y squared. When x is negative, negative x is positive. So the absolute value of this, the absolute value of negative x, is just negative x. Negative x minus y squared is the same as what we got before. Debating if I should write... This is tough. You know what? I'm going to write this out. Feel free to skip ahead a little bit if you don't want to see. If this makes sense, if you could explain this to your mother, to your own mother, assuming she's not like a mathematician or something, someone in your family who's not a mathematician, if you could explain this to them, then you can move on. If you can't, then maybe it is worth seeing this explanation again. So let's separate it into two cases. X is positive, or 0. X is greater than or equal to 0. Then let's look at, let's do this actually. Ooh, beautiful. So x is positive, x is negative. Now we're going to look at x triangle y and negative x triangle y. X triangle y when x is positive, this is x minus y squared. If x is positive, then the absolute value of x is just x, because it's positive anyway, so we don't have to worry about absolute value. So this is x minus y squared. If x is negative, then the absolute value of x is the opposite of x. Think about it. If x is negative, pretend it's like negative 2, then the absolute value of negative 2 is 2, which means that the absolute value of this negative number is whatever the opposite of it is. So we have negative x minus y squared. Negative x triangle y. If x is positive, then negative x is negative. Okay? So then the absolute value of negative x is whatever the opposite of negative x is, which is just x. So we end up flipping that first term. Since x is positive, negative x is negative, we flip that first term. If x is negative, negative x is positive, we don't flip the first term given the absolute value. So notice that these two right here give the same answers, whether x is positive or negative. That means that B is your answer. Let's quickly talk about C, D, and E. Let's quickly talk about C, D, and E. If x triangle y is 0, then y is 0. If x triangle y is 0, then y is 0. No. Or if absolute value of x equals y squared. If x triangles y is 0, then y equals negative x. Excuse me. If x triangle y equals 0, then absolute value of x equals y squared. Which means that this implies that x equals y squared or negative y squared. Or x equals negative y squared. Not y equals negative x. No. Here, then, what we would have to do to get a plain old y here, we'd have to take the square root of these. And we'd end up taking the square root of the x. So the square root of x equals something with y's, but not just negative x. So that's not going to work. No. No, no. If x triangle y is 1, then y is 0. If x triangle y is 1, then the absolute value of something minus y squared gave you 1. If x triangle y is 1, then, not an h, x minus y squared equals 1. Absolute value of x equals 1 plus y squared, which means that x equals 1 plus y squared, or x equals negative 1 minus y squared. It's one of those two. Can we have an example here where y isn't 0? Absolutely. Y could be 1. In that case, x is 2. Yeah, if y is 1, then x is 2. Absolute value of 2, yeah. If y is 1 and x is 2, then we have a y non-zero satisfying this and not satisfying that. So there we go. That's why all the so if you were looking at E, like why isn't it E or why isn't it T? Why isn't it C? Why isn't it A? Hopefully I've explained that thoroughly. 39. A lot of function stuff on this one. If f and g are functions defined by a function of 3 variables with 0, or f is a function of 3 variables where the projection onto the second variable is 0. I don't want to use those words. So that might not even be the right usage of those words. So f of x, y, z equals x0, z. So, okay, we'll talk about that in a second. G of x, y, z is x, z, y. Oh, this is just kind of, they just give you a couple rules and you have to follow the rules. It's actually not that hard. I mean, it's not hard at all. Okay. Well, I was going to talk about like what this means. I thought this was going to be like a deeper problem. What does this mean? It means that f of x, y, z is independent of y. because it's the same as x0z. We won't even go into any of that, any of the specifics. G of x, y, z equals x, y. Okay, so we're looking for g of f of 0, y, z. So f of anything, x is x0z. So f of 0, y, z is equal to 0. It's equal to the triple, triple, 0, 0, z. Because whatever y is, it brings it to 0. X was 0, and z just goes to z. Okay, so now we're looking for g of the point 0, 0, z. What does g do? It flips the second two coordinates. So we have, we now have the point, so whatever x was stays the same, so it's still 0. Y goes to z, and z goes to y. So it's Ozo. Very good. A. 40. I do want to not dwell on these, although these are the most important questions. These are the hard ones. These are the ones that everybody struggles on and everybody asks about. Not always, though. I don't know. The equation ax equals a plus 2x is the solution for all values of a except... Alright. So ax equals a plus 2x. So we're looking for a solution for values of a. So let's solve this equation for a. We have ax minus a equals 2x. We can factor out an a. Ax minus 1 equals 2x. That means that a equals 2x over x minus 1. Which means that this has a... there's a value for a for everything except where x equals 1. Whoopsies. I think I solved it for the wrong variable, didn't I? Yeah, a equals 1. Whoops, no, I solved this for the wrong variable. Whoops. So ax equals a plus 2x. So we gotta solve this for x. So then negative a equals negative ax plus 2x. I just flipped around these two terms. And negative a equals x times 2 minus a. Forgive the sloppy work here, as in like I'm just doing like weird work. I mean, I'm still getting the right answer. So negative a over 2 minus a has to be equal to x. That means that a, if a is 2, then we have a problem, which means that our answer is E. A equals 2. It's confusing which one you need to solve for. Solution for values of a. Yeah, you need to have it solved for the other variable, which means that 40 is E. Yeah. Wow. Function f is defined and continuous on the set of real numbers. If f of 2 is negative 3, f of 4 is 6, and f of x is 0 for exactly one number x, then x could be... Oh, this is a... So, that's kind of a fun problem, I guess. So, has to be, yeah. So that's kind of cool. So okay, so we know that if we plug in 2 into our, so we have some function out there where f of 2 is negative 3. So this is 1 point on our, so this is 2. This is 1 point, 2 negative 3, and then we have another one, f of 4. F of 4 is positive 6, so like way up here. So these are 2 points on our function. Other than that, we know nothing about our function. So it could do crazy stuff. Well, defined and continuous. Let's not go too crazy. It could do crazy stuff. Maybe it's like that. Who knows? And we don't know about the other side either. I mean, it could be just, it could be really wild. Who knows? Who knows? F of x equals 0 for exactly one number x. hold on, let's draw that better then. F of x never equals 0 on any other point. So it actually has to look like that. So for exactly one number x. So somewhere between 2 and 4, it has to cross the x-axis. So the only possible answer choices are ones between, I suppose, not equal to 2 and not equal to 4. So the only one that's between 2 and 4 is D. Cool problem. Whoa. 42. We got a plane. A plane flying at an altitude of 8 kilometers is headed directly towards two cities A and B, shown in the figure. If the angles of depression to the cities are 39 and 27, how far apart are the cities? Ooh. So how far apart are the cities? This is X. That's what we're looking for. So that means we're looking for X. I see this triangle here, so and I know that this triangle has this smallest angle of 12 degrees. I don't know if that's interesting yet, but that's just what I'm looking for. So we're looking for X. We know 8. We know this is a right angle. This is 8. Okay. We know this angle right here is 51 degrees, which means we know this angle to be 39 degrees since this is a triangle. Or you can also consider the alternate interior angles there. Since this is 39, the total sum on this line has to be 180 degrees, which means this is 141 degrees. Which means that we know this angle. This angle is I think we could have gotten that faster, but yeah, we could have added 51 plus 12 and just done that. Yeah, but okay, so 141 plus 12 is 153, which means we need 27 more degrees to get to 180. So that's 27 degrees. 51 plus 12 is 63, which means we need 27 more degrees to get to 90. So yep, that all works. So we got a lot of angles. We seem pretty good, right? We know all three angles. We know all three angles in this triangle. We know nothing about the lengths of these two triangles. But we do know this 8. So we're going to have to use this 8. Yeah, let's think about this triangle right here. This all the way across, all the way up. We're going to think about this triangle because I think we can do something useful with this triangle. So this is 8. This is 27. This is a right angle. So this is 63. So we can figure out, we'll call this y. We can figure out y, definitely. So the tangent of 27 degrees equals 8 over y, and this means that y equals 8 over tan 27. So we can get y. That seems useful. 8 over tan 27. In my calculator, we're on degrees. So this is 15.7. We'll say y is approximately 15.7. It's 700, so I'm just going to say 15.7. 15.7 miles? Kilometers. Okay. So y is 15.7 kilometers. And there's another triangle here. Right here. Which means, let's call, we'll draw it. Still 8. We'll call this z. And we know this is a 90-degree angle. This is now 51 degrees, and this 39. And quite similar to before, tan 39 equals 8 over z, which means that z equals 8 over tan 39. We'll just do that. 8 over tangent of 39. 9.879 approximately. You're going to keep these numbers in your calculator so you can use the full numbers. But about 9.879. Forgive my significant figures. Kilometers. That means we know that x is going to be y minus z. So that's about 15.7 minus 9 point whatever all that was. So we take that first 15.7 and subtract the second, meaning we get 5.82. Hope I didn't do that one right. Or I hope I didn't do that one wrong. Because I get about 5.82. I get 5.822. That looks good. But the question is that the fastest way to do it? I think, so the key to this problem, and the key to doing it fast, is identifying what you're looking for. So let's use a color we haven't used yet. Orange. So we identify what we're looking for, x. And what do we know? We know this 8, we know the 27, we know the 39. So if we can figure out the whole distance here, all the way across, and then if we can subtract this smaller distance, figure out the whole distance, subtract the smaller distance, that's how we can get x. And both the whole distance and the smaller distance that I'm talking about here, both are going to incorporate this 8. And we can do some angle chasing, get some angles, and we could definitely figure out what these lengths are in order to get x. Is there a shorter way? I bet there is. I bet there's a shorter way here. I would love for someone in the comments, if you know of a shorter way to do this problem, let me know. Obviously, if you're doing this on the day of a test, you don't have to write all this stuff out. Like, if you can, in your head, see these tangent formulas right here, then, I mean, you're probably good. And you don't have to write everything out. You do this stuff on your calculator, you do the subtraction, you get the answer. But yeah, let me know if you know of a faster way. The equation 4x cubed minus 3x squared minus 1 equals 0 has how many non-real roots? How many complex roots? Okay, so here's a fact for you. In a polynomial, this is a polynomial. Well, this is a polynomial with real coefficients. There cannot be an odd number of complex roots. Now, the way to say that is, for every complex root, there is a complex conjugate root. For every complex root, there is another complex root. So, For this, it either has no complex roots or 2 complex roots. You can't have a cubic polynomial with 3 complex roots. It's not possible. You can only ever have an even number of complex roots. There cannot be 3. There cannot be 1. There certainly can't be more than 3, because for every cubic polynomial, there are only 3 roots, period. So either 2 of them are complex or none of them are complex. Now that we get that out of the way, we have a cubic polynomial, 4x cubed minus 3x squared minus 1. Okay, I want to say if you have a graphing calculator, you already know the fastest way. You're going to plug this into your graphing calculator. You're going to see how many times it crosses the x-axis. If it crosses the x-axis 3 times, the answer is 1. If it crosses the x-axis once, yeah. Sorry, let me say that again. If it crosses the x-axis 3 times, so like it'll look like 1, 2, 3, then you know the answer is none. It has no complex roots. All of its roots are real. If it crosses the x-axis just once and then does this little loop either below or above the x-axis, then you know that there are 2 complex roots. That's what I'm going to do. And then I'll give it another quick thought. So 4x cubed minus 3x squared minus 1. It does its loop below the x-axis, which means that we know the answer is 2. Is there a way to know that? One second. Is this 43? Yeah. Okay, so I do believe that 43 is C. Is there a way to know that without plugging it into your calculator? If there is, I'm not sure of it right now. I don't know it. Is there a way to immediately know that there are 2 complex roots there? Or only 1 real root? You have to figure out what the real root was. And then notice that you have an irreducible prime polynomial. If you know of a way in the comments, please tell me. Very interested, but I don't see one. So, okay. John leaves home at noon, driving at 50 miles per hour for T hours. His wife, Anne, leaves home an hour later, driving at 60 miles per hour on the same straight road. It's like one of those math problems that people say to, like, in like movies and stuff. His wife, Anne, leaves home an hour later, driving. Which of the following represents the distance between them? T hours after noon. Okay. All right. So let's try a little graph, and this is going to represent time, and this is going to represent distance from home. So John leaves home at noon, driving at 50 miles per hour. So he's in his garage, and he just starts at 50 miles an hour, just crazy, flies out of the garage. So he goes at 50 miles per hour. So that's it's gonna be constant. So the slope is 50. So for every hour that passes here, let's say this is the one. This time is in hours. This is 1 hour. He's traveled 50. So right here, it's gonna be 50. So yeah, 2 hours. He's gonna have traveled 100 miles. So an hour, He's driving for T hours. Whatever. This extends for T hours. So an hour later, she starts driving, and her function is going to be 60 miles per hour, so it's a little bit steeper. So she's going at 60 miles per hour, which means that after 1 hour, she's going to have driven 60, and after 2 hours, she's going to have driven 120. Wherever that, so the drawing isn't perfect, but wherever that would come up on the drawing. Essentially what we're looking for here is the difference between these two functions. So this turns out to be the rightmost function minus the leftmost function. So 60 T plus 1 minus 50t. And then distance is absolute value. Well, this is not the right way to go about it. This is absolutely not the right way. So let's do it the right way. I tried to do it like a sneaky way, but I don't like that anymore. So we're gonna do it the more normal way. We're gonna actually so Anne is traveling 60 miles per hour and he's traveling 50 miles per hour. So the distance between them, once they're both driving, is however far they've driven. So after 1 hour, how far are they going to be apart? That's the question you got to ask. After 1 hour, how far are they going to be apart? After 1 hour, they're going to be 50 miles apart. Because that's after the first hour. So they're going to be 50 miles apart at t equals 1. 50 miles apart. At t equals 2, they're going to be how far apart? Yeah. So forget the graphs here. John and Anne. After 1 hour, John is going to be at 50, Anne is going to be at 0. 2 hours, John is going to be at 100, Anne is going to be at 60. 3 hours, 150, 120. Which one of these satisfies this relation? Okay, so when at t equals 1, the distance between them is 50. So we'll indicate the distance between them as the subtraction, and we get 50, 40, 30. So at t equals 1, which one gives us 50? 10t minus 60, absolute value. This one does. At t equals 1, 10t minus 50, that one doesn't. 10t minus 10, no. T equals 1, 20, no. T equals 1, this one doesn't either. Oh, forget all this then. All you need is this first hour. For t is greater than or equal to 1, just take t equal to 1. At 1 hour, John is 50 miles, Anne is 0 miles. That's the only one that satisfies this relation. Wow. The answer has to be A, just for that reason. I was overcomplicating it. Interesting. Very interesting. That's definitely going to be pretty quick if you do that pretty quick. All right. Ooh, this looks like some cool stuff. Which following expressions are equal to 1 for all real x between 0 and pi over 2? Okay. So 1. Sine 2x times cosecant 2x. I immediately think of changing this cosecant into a sine, because then this is sine 2x over sine 2x, which is always equal to 1. So 1 is always true, so it can't be B or C. Let's skip 2 for a second. Let's look at 3. So the square root of sine squared x plus cos squared x. Sine squared x plus cos squared x is 1. That's a definition. The square root of 1 equals 1 for all values of 1. So 3 is also guaranteed to be true. Okay, so now we're left between D and E. We have to determine, is 2 sine x cos x always equal to 1? So you see 2 sine x cos x, and you think, wait a minute, this is one of those identities. 2 sine x cos x is sine squared x. Or is it? Or wait, I thought there was another one. Isn't it like 1 minus cos squared x equals sine squared x? Is this one cos squared x? I'm not sure. I don't remember my trigonometric identities. Oh, wait a minute. Was this sine 2x? So you're someone who doesn't remember their trigonometric identities on the day of the test. There are lots of them. I don't necessarily blame you. You should put them on flashcards and you should memorize them all. In reality, this is what that's equal to. But if you notice with any of these, whatever you think, none of these are constant for all values 0 to pi over 2. None of them are constant. They all vary a lot. So 2 could never be constant. Even if you didn't remember exactly what the identity was, you could remember that it's certainly not constant. And let's say that you were still unsure. Plug in a couple of values into your calculator. 2 sine x and cos x. Plug in, I don't know, pi over 6 and pi over 4. You'll notice that neither of them. Don't do pi over 4. Plug in pi over 6. You'll notice that it's not 1. Move from there. And therefore, you know the answer is D, not E, is D. 46. Certain population of bacteria grows 10% larger each day. The population 100 days from now will be how many times the size of the population today? So we have a certain population of bacteria, and it grows by 10% per day. So we're asking P times 1, let's not mess with that, 1.01 to the 100th power equals, let's say, xp, where we're looking for x here. So it's how many times bigger than p. So we can first divide both sides by p. 1.01 to the 100th power equals x. And this means that, say, the well, yeah, we can just use your calculator. 1.01 to the 100th power is 2.7048. Oh, obviously. This is not 1.01. This fact that this looks like 1.01 just confused me. Jeez, making way too many mistakes here. 1.01, this is 1.1, which means this is 1.1 to the 100th power equals x. Sorry about that. So 1.1 to the 100th power gives us 13,781. There's our answer. Now, how do I know that this is what the formula looks like? So, if it grows by 10% each day, then after one day, let's say it starts with one bacteria and it's like, it is able to reproduce asexually. So, it starts with one, it grows by 10% each day. By the second day, the population is going to be 1.1. That's a little iffy, but whatever. By the third day, it's going to grow by 10%. So, it's going to be 1.1 times 1.1, right? It's going to grow by 10%, and that's going to give us something. And then whatever the third day is 1.1 times 1.1 times 1.1, which means that it's going to end up being 1.1 to the d number of days. And that's how we get this sort of growth factor with an exponent. And you put the p in the front is just the initial population. This is like those exponential growth models that you should be familiar with. 47. 2 hours, 43. Hopefully we can finish this pretty quick. Which of the following is the set of all real numbers x for which there are points on the graph? The set of all real numbers x for which there are points on the graph of y equals negative x squared. Where there are points on that graph. So, oh, what an interesting problem. Okay, so what could I plug in here for x to give us a real valued y? Well, could I plug in something, say, positive? Well, if x is positive, then x squared is also positive. So here's what we're doing. X is positive. Then x squared is also positive. Negative x squared is now negative, which means that the square root of a negative number is not real. I'll write that a little better. So the square root is not an element of the real numbers. It's a complex number. So if x is positive, so it can't be positive. It's certainly not positive, not all real numbers. All right, let's take a look at negative numbers. Let's say that x is negative. Okay, then x squared is now positive. Negative x squared is negative. The square root of a negative number is not an element of the real numbers, which means it can't be negative. Okay, what if x is equal to 0? Then x squared is 0, negative x squared is 0. The square root of negative x squared is also equal to 0, which is a real number. We could graph it, which means that it's B, and not A. The set containing only 0. Brilliant. Fun question. So I completely misinterpreted problem 48. This is me coming in after the fact, and I as a result, I got problem 48 wrong. So problem 48 says, we have a value frequency table and the frequency distribution above. The mean of the distribution is equal to one of the values. What is the frequency of the value 4? I just interpreted this in totally wrong. So, so our mean is 0 times 1 plus 2 times 3, 3 times 2, 4x, 5 times 1 over 1 plus 3 plus 2, which is 6, 7, right? Yeah, over the sum of all the different things. So we have 1, 4, 6, 7 plus x over 7 plus x. So this is essentially 6 plus 6 plus 4x plus 5 over 7 plus x, which is 17 plus 4x over 7 plus x. And we can plug in these 5 values from here into this and see which one gives us a mean that is equal to one of the values. So if we plug in the value 0, so 0 implies 17 over 7. That doesn't work. If we plug in 2, 2 implies 25 over 9, which again, that's not even an integer, so it definitely doesn't work. 3 implies, let's see, 29 over 10, which again, not an integer. It can't be one of the values if it's not even an integer. So we'll try 4. 4 implies 33 over 11, which is equal to 3. And what do you know? That is one of the values. So this means that the answer is D, 4. And just for the sake of it, we'll try 5. 5 implies 37 over 12, which again, not an integer, definitely not up there. So the answer is D, and that's why. Back to the regularly scheduled programming. Which of the following intervals contains all the values for x for which x squared is less than 4? Which of the following intervals contains all of the values of x for which x squared is less than 4? Okay, if x squared is less than 4, then x is between -2 and 2. So if x squared is less than 4, well, 2 squared. If x is 2, then we're good. If x is 0, then we're still good. If x is -1, we're still good. If x is -2, well, 2 is not good. 2 is not less. 2 squared is not less than 4. 2 squared is equal to 4. So it's strictly between these two. So yeah, this does not contain all the values because 1.5 is a value, for instance. This does not, wait, yeah, that works. -1 to 4, this doesn't contain all the values because -1.5 works. This doesn't contain all the values, this doesn't contain all the values. So the answer is B. Yeah. I don't know why that's challenging. It's a weird question, but I don't know why it's hard. Let me know in the comments if there's something I'm missing there or why you were confused about it. Okay. Oh, so much reading. In a biology class, 3 multiple choice tests were given. In a given test, each question was worth the same number of points. The table above lists the number of questions answered correctly and the total number of points received by each of the 3 students. How many points were awarded for each question on test 2? Three multiple choice, and on a given test, each question was worth the same number of points. Oh, so this is a 3-variable system of equations? Brutal. Gotta be a better way to do that. I mean, I could do some, row reduction pretty easily. They have this nice and arranged in a... but no, I don't want to do that. Is that what we have to do? I wonder, so all of the test questions were probably worth a positive integer number of points. So like for test 1, they were probably worth some positive integer number of points. Same with test 2 and test 3. If that's true, there's some linear combination of test 1, 2, and 3 that give 177, given 34, 15, and 9. Like, so let me just try something. What if the weighting was like 2, 3, and 4? So it would be 2 times 34. I have no idea. 2 times 34 plus 3 times 15 plus 4 times 9. I'm under. Not that far under, though. What if it was 3, 4, 5? So 3, 4, 5. Now I'm way over. What if it was 2, 4, 5? 173. Ooh, that's so close. It's off by 4. Interesting. It's off by 4. What does that mean? Oh. What if it was 1, 2, and then like 10? Oh, that doesn't do it. Oh, wait. It might. Just messing around on the calculator a little bit. Yeah, that doesn't do it. Am I gonna do some row reduction? I don't want to. If I was on the test, I think I would though, because the row reduction actually isn't that bad. You turn it into a 2-variable system pretty easily by subtracting the second from the first. Wow. I think. So most calculators have a way to just solve these matrices and do the row reduction for you, including this one. I know on my calculator I can solve 3-variable systems instantly, basically instantly. I don't know if I want to do that though, because there's gotta be something. Gotta be something here that I'm not seeing. Wait. $35 plus 33 minus 34 is 34. So Latoya minus 1 plus Sue equals Sue. Latoya minus 1 plus Sue It's just not quite. Are the rows not linearly independent? I think they are. What? Oh, we're going on 3 hours. Darn it. Maybe I can make an easier 3-variable system. Maybe this is going to be what I do. So let's say we're going to call this L, J, and S. We're going to consider L minus S. This is, so we're going to make a matrix. L minus S is 1, 2, 1, 12. So theoretically, this would also be a distribution of possible scores, and you'd have to get 12. That's interesting. So like 3, 5, and 2 would work here. But so would 5, 2, and 3. So let's just try that. 3, 2, and 5. 3 times 34 plus 2 times 15 plus 5 times 45. Oh, way too big. So the first one probably isn't a 3. Okay, so what if the first one was like a 1? $289, still way too big. One, two, three doesn't work. Oh, all right, I'm back. So I was just sort of staring at this question for a while, and I've come to the conclusion after staring at it that the fastest way is to use the row reduction thing on the calculator, like I explained. And if there is some faster way, like you didn't miss anything. I just wrote out these equations. I've actually erased them and wrote them again, I think. I don't even know. So yeah, if there is a faster way, I'm not, well, not a faster way. If there's a way to do it without the row reduction on the calculator or in real life, I mean, well, the calculator is way faster than real life, especially in this circumstance. If there's just a way to do it that's better than that, this is an annoying problem. I don't see it. I absolutely don't see of a better way. I don't see of like a quick way. You know, most of these problems have that quick way, and for the life of me, I can't. I don't see it. I don't see some monumental quick way to do this. There has to be, though, right? If you know of that quick way, please let me know. Please put it in the comments. But in the end, this answer is B. And the best way that I know how to do it is to use that graphing calculator, row reduction. So yeah, that's it. Thank you for watching. If you did watch all the way through, you're pretty crazy. I hope you did well. I hope I did well. I'm gonna check my answers, and I'll catch you guys next time.